So now that we have this cool simulation working for the whitewater, let's go ahead and set up some renders for this. So let's first jump up to the object context and create a new geometry object for these whitewater particles. I'll make this red as usual to match my other render objects and call this render whitewater close-up. And we can turn off the display flag on this and dive inside there. Drop in an object merge, and we've already set up a render null to reference here. So we can point this object merge to object/whitewater closeup/render whitewater. If we set the viewport to hide other objects, we can see it's bringing in those particles correctly, so that looks all good. And then back on this geometry object here, let's go to the Redshift Object tab, and under Settings and Render, let's enable Velocity Motion Blur by turning on Mesh Deformations Blur from Velocity attribute. And we also need to render these points as particles. So under Redshift Object and under the Particles tab, we can enable this Render Object as Particles option. And of course we need to set up a shader for this that we'll assign on the Render tab. So going over to the Material context, let's create a new whitewater material. So drop in an RS material builder. I'll call this RS_whitewater and dive inside there. And we don't have to get very complex with this whitewater material. We can just set this to be white. Although for the final version of my shot, I set this slightly above a plain white value of 1. I set it to 1.1. Of course, you can play around with making this even brighter if you want to, or a bit darker. You can use your artistic judgment there. And I turned on a bit of reflection here. By default, this has a reflection weight of 1, so I just wanted a little bit of reflectivity to these particles. Just a little bit over 0.1 should be fine. And by default, this doesn't have any refraction/transmission weight, so we can turn this up a bit as well. And everything else we can leave on its default. Just a little bit of refraction, little bit of reflection, and a slightly super bright white. So now let's go back to the object context. Then for this render object for that whitewater, on the Render tab, let's assign that material. So we'll point this to mat/rs_whitewater. And then jump over to the out context. And we have an existing render ROP for this water close-up shot. I'm just going to add the whitewater into this render so that the water surface and the whitewater are nicely integrated with each other. So on this water redshift ROP, let's go to the Force Objects and add the render object for that whitewater close-up and accept that. So this looks all good. And for these initial test renders, I'm going to turn down some of the settings. Actually, it looks like automatic sampling is already disabled from our previous render tests with this water ROP. So I'll leave this sampling set as it is here. For the final renders, I'll turn on automatic sampling, but for the tests, some min samples of 4 and max of 32 should be fine. Although maybe I'll set the max down to its default of 16, just to speed up our test renders a bit more. We can also disable global illumination. This will also speed things up quite a bit in our test render. So with all of that set up, let's open up the Redshift pane. Under Houdini, select ROP, we'll select that water close-up and run our initial render. So this initial frame here looks like it's working nicely, but there is one thing you need to watch out for when using this render view pane, because some of these options for Redshift are off screen here. You can see those if you hit this little arrow. It'll show those missing options that don't fit on this current bar right now, or you can just make this view quite a bit bigger. And you can see that when I resize this window pane here, it's restarting my render, which we very likely don't want. Maybe for some design workflows this could be nice, but generally I don't want this render restarting if I change the size of this window here. So this render size is set to fit window. So I'd recommend setting this to original size, so it's always rendering the same size and it won't change just from changing this window here. Or if you prefer, you can set it to a fixed scaling. So right now that's on 28, so it's doing a low res copy of our render, which might be fine for some of our tests. I'm going to set this to 50%. That's certainly speeding things up quite a bit. I'll stick with 50% for the moment while dialing in these tests here. Now this whitewater render is already looking quite nice. If we compare this to the finished water shot, you can see that we're not very far off from this. And of course there are some lighting differences, and the lighting can change quite a bit when we re-enable global illumination, so I wouldn't go too far with trying to dial in the exact colors without global illumination enabled. So for our next renders, I'll go back to that Redshift ROP and re-enable global illumination here. And at this point, it's just a matter of tweaking your lighting and your whitewater shader to suit your artistic judgment. But there are a few things that I should point out as well. If we go back to the whitewater setup, you can see that the color and alpha attributes are being modified and then passed into the render object. However, this is a bit misleading because the shader isn't using these color and alpha attributes at all. If you wanted these attributes to affect the shader, you would have to import those attributes in the shader and then wire them up accordingly, which I really don't feel is necessary here. If you wanted to do some more customized stuff, like treat the spray different from the foam, different from the bubbles, then maybe you would want to get into some attribute-driven changes to the shading on those particles. But I didn't find it necessary for my shot. So to make it a little bit clear exactly what's happening here, I'm going to disconnect these attribute modifications from the render object. I'll just connect this render null directly to that sim scale inversion and create a new null after these attributes and call this visualize. So this should make it more obvious that this color and alpha is just being set for the display, and the actual look of these particles is controlled on that shader. Another thing worth pointing out is that you can modify the point count before rendering. So if you wanted to reduce the number of points, for example, if you simulated incredibly high res and it was making the render just far too slow and heavy to render that many particles, we could reduce the particle count for rendering. More particles does generally lead to better render results, but if you want to reduce the point count, you can use a delete SOP, set the entity to points, and the operation to delete by range, and I'll set this to select 1 of 100. And then flip this to delete non-selected and display that delete. So now we're only keeping 1% of our particles here. If we change this 100 down to 10, now we're keeping 10% of our particles. So if you really do need to reduce the point count, this is an option to do that. And on the flip side, you can increase your point count and bulk this up a bit with a point replicate. Now the point replicate is not going to give you results that are as nice as simulating with more particles, but this is a way to force more particles in at render time. So we could set this to 10 points per point, display that point replicate, and then on the shape tab, perhaps scale up those replicated points a bit. So this will give us a more dense point cloud. Like I said, this isn't as nice as simulating with more points, but it is something that you can play around with if you do need more points at render time. So I'll just delete those for now, since I'm pretty happy with the point counts we are currently working with. Now if we go back to our Redshift ROP and our render view here, we have re-enabled global illumination, but we haven't re-rendered with that yet. So this current frame buffer here is the version without global illumination turned on, and I'll take a snapshot of that. And now let's re-render this with this global illumination. And as this is re-rendering, you can see that with global illumination turned on, this white water is showing up quite a bit brighter. So this is why it's a good idea to not go too far with dialing in the perfect brightness and such on your shader and your lighting without that global illumination turned on, because that really can make quite a big difference in how everything looks. So you can get things fairly close without global illumination, but that certainly should be on as you finesse things. Now this half resolution test frame is looking quite nice, and of course we have to render the entire shot to see how this looks in motion and then potentially tweak accordingly. but once you render this entire thing to disk, you should wind up with an end result that looks something like this.